Today we are talking about similarity and congruency. So we're talking about congruent figures. The first thing we need to look at is some definitions. Similar figures have the same shape, but not the same size. Similar figures have the same shape, but not the same size. The symbol for similarity is what I call a squiggle. Looks like that. So when you see this symbol right here, this little squiggly line, that means it is similar to. Remember, similarity is same shape, but not the same size. Congruent figures have the same shape and the same size. And the symbol for congruency is the squiggly line with an equal sign, because they're exactly the same. Okay? A similar triangle has corresponding angles that are congruent and corresponding sides are in proportion. So the angles, we're going to use the congruency sign, and for the sides, we're going to use the similarity sign. When we are identifying corresponding parts, we need to make sure to use the correct symbol. It's also important that we make sure we know how to name the triangles so that they are lined up properly when we name them. This first triangle has vertices, which is plural for vertex, vertice A, B, C. So I'm going to name that triangle, triangle A, B, C. You name a triangle based on the vertices, what letters the vertices are. So triangle A, B, C is how I would name this triangle. The smaller triangle is turned upside down. Okay, so I'm going to have triangle X, Y, Z. And I'm going to name that in that same order. X, Y, Z. When you're looking at similar or congruent figures, the letters are going to tell you your corresponding parts. Okay? So if we look over here, this line on top of AB tells us we're talking about the sides. Okay? So I am talking about side AB. So I'm going to highlight my side AB. And that side is going to be similar, so I use the squiggly line, to the side XY in the smaller triangle. Side AB is similar to side XY. Okay? And you can see that also in the letters of the name. So in the name AB, the side AB comes first. In the smaller triangle, XY are the first two letters. So you know those are the corresponding sides because they are in the same position. The next one is side BC. So we're going to look down here at side BC is going to be similar to side YZ. BC are the last two letters of the name. YZ are the last two letters of the name. So you know they are corresponding. And it's a side, so they are similar. And the last one is side AB, which corresponds to side XZ. The first letter and the last letter correspond to the first letter and the last letter. So side AC is similar to side XZ. The next part is to identify the corresponding angles. When we are looking at angles, we use this little half triangle or angle symbol, okay? And we are going to write angle A is congruent to angle X. The first letter of the name is congruent to the first letter of the name. The next one is going to be B is congruent to Y. Angle Y. Notice in the name, B was in the middle. Notice in the name, Y was in the middle. So that means they're in the same position. And the last one, C, angle C, is going to be congruent to angle Z. All right. For example 2, this time we're looking at two squares. They could be rectangles. We don't know for sure if they are congruent or if they are similar because they didn't tell us. But we can go ahead and name them. I'm going to start with the letter E, and I'm going to go in a clockwise motion to name this rectangle. So I'm going to say E, F, H, G. So E, F, H, G. You just kind of go around in a circle to list all of your names. You could go counterclockwise, but whatever direction you do for one, you do the same direction for the other. So that means the second one, I'm going to start with M, and I'm going to go in a clockwise motion. So that name is going to be M, N, P, O. Yeah, I just kind of cut off at the bottom there. Should be an O. So we need to identify our corresponding sides. Corresponding sides are what? Similar or congruent? Similar. So, at EF, I'm going to name that EF and put a line on the top. That lets me know I'm talking about side EF is similar to what side of the second rectangle? M, N. Okay? Based on the way that I wrote the name, EF is in the same position as MN.
That's why they similar?
Mm-hmm. Okay, the next side, I'm just going to go around. FH would be similar to what? If FH was in the middle,
it would be similar to NP.
NP. Right? Look at your name. FH is similar to NP. So FH is similar to NP. And the bottom side, we have GH, or you could say HG, either way. GH or HG is similar to PO. Yep, down here at the bottom.
It's easy.
Again, looking at the name, H and G are side by side, P and O are side by side. And our last one is GE is going to be similar to what? OM. Because of the way we named the rectangles. So now we have to identify the angles. Angle E is congruent to what angle? M. Good, they're in the same position. Sorry. Angle F would be congruent to what angle? in. Good. Angle H would be congruent to angle P. And angle G, sorry, would be equal to angle O. The next part is determining if something is similar. We determine if something is similar by writing a ratio of the side lengths. So we are going to write a ratio, which is a fraction of the side lengths. So I'm going to compare the two sides that are given to me in the first triangle compared to the two sides of the second triangle. Okay? But I'm writing it as a ratio. So for the first triangle, DEF, they tell me the side DE over the side EF. So what is the measure of side DE? 9. So I'm going to say 9 divided by 6, because EF is 6. That can be simplified to the fraction 3 over 2. Is everybody okay with that? I took the two side lengths of the first triangle and I divided them. I wrote them as a ratio. 9 divided by 6 simplifies into the ratio 3 over 2. Now 3/2. Now I have to do the same thing in the same order to the second triangle. So I need to know the corresponding sides. What side corresponds with DE? This one over here, which is QR. Okay? The DE side, which was 9, corresponds to the QR side. So I'm going to say QR divided by this bottom side, which is RS, leaves me with 3 divided by 2. We now see that I have the same ratio for both triangles, so they are similar figures. How do you know if something is a similar figure? Because they have the same ratio. Okay, our next example is number 4. This time we don't have letters, but we need to make sure that we write the ratios the same. So we have two rectangles, and I want to determine if these two rectangles are similar. So I'm going to write a ratio for the smaller rectangle. The 80 side, the longer side, divided by the shorter side. Okay, so I'm going to say 80 divided by 12. That can be simplified to 40 over 6, which then simplifies to 20 over 3. You could change that to a decimal if you prefer decimals, but we're going to leave it at 20 over 3. Okay, that's as simplified as I can make that fraction. But now I need to set up a ratio for the second rectangle, and I need to make sure that I do it in the same way. So the smaller rectangle, we said the long side divided by the short side. That means in the second rectangle, I need to set it up long side divided by the short side. So we have 120, that's our long side, divided by 18, which is our short side. That could simplify by 2, which would give you 60 over 9. Which then could simplify again into 20 divided by 3. Noticing that they come out to the same ratio, We know that they are similar figures. Because of the same ratio. Okay, for our last example, we're going to do the same thing. This time we just have a parallelogram, and we need to set up our ratio for the larger parallelogram to the smaller parallelogram. Make sure you set it up in the same manner. So we are going to set this up with the smaller side divided by the bigger side. So the smaller side is 150 because it's a smaller number, divided by the larger side, which is 200. I can simplify 150 divided by 200 by dividing out the zeros. So I get 15 divided by 20. Okay, and then you can simplify 15 divided by 20 into 3/4. Again, you could just put this in the calculator and get a decimal, and you could get the decimal at 0.75. Okay? We need to do the same thing to the second parallelogram. We did the smaller side divided by the bigger side, so that's what we're going to do here. 30, because that's the smaller side, 30 is smaller than 40, divided by 40. Because both numbers end in a 0, you can just cancel out the zeros. Okay, it's the same thing as dividing by 10. So we get 3/4. They have the same ratio, so they are similar figures.